So here's our code for checking to see if a number is prime. At the very top, we ask them to enter a possible prime number, and we read it in with the scanner. And then we have a loop that checks. And the way we check is we count from 1 to the number that they enter, num being the number that they enter. And if num divided by that counter, if num modulus the counter is equal to 0, we know it's evenly divisible, and that makes it a factor. So we increment the number of factors. And the definition of a prime is a number that has exactly 2 factors. So by the time we get down here out of our loop, because I is increased, then if factors is equal to 2, then it's prime. And then we print out that result or not. Then the next thing we're going to do will be to turn that into a for loop. Already got it done? I don't see a for loop. Oh, yeah, we're supposed to turn that into a for loop now. Oh, the 0 goes before, or excuse me, after the dot. We had it before the dot. Okay. Cool. Should I say? We have to kill the old one. How about doing factorial? Just 10. All right. Let's see what the error is. What it's saying is invalid format specifier. This is nothing else. There, that one. Again. Oh, this is your mouse. Okay. Oh, man, you have amazing attachments. Okay. I think now it's saying build is successful. So let's run. Okay, what number? Oh, right. Yeah, it is proper. There. And it's blowing out. We want to see. It's not happening here. Oh, that's supposed to be percent. Move this up a little bit. Oh, we had V declared here. We don't need to redeclare it there. Let's get rid of that. Oh, and we have a semicolon there, which is why we redeclared V. Never put the semicolon on the end of a loop statement. There we go. I don't do that too. Here we go. Let's go now. Try 10. Cool. Yeah, that looks good. So if I was going to turn this into a for loop, I would do this. For int I is equal to 1, semicolon, I is less than or equal to num, semicolon, I plus plus. And then I come down here and I delete that I plus plus down here because that increment is done up there. So that's what I changed. I took that int I is equal to 1 and I put it as the first line of the for statement. And then I put the condition of the while loop right there. And then I took that iterator out, which was down here, and I moved it up there as well. And we certainly could make some improvements. If something is not divisible by 2, we know it's not divisible by 4, for example. So once you've checked 2, you don't need to check any more even numbers. And also, you really only have to go halfway up to the number. Because if you're going, but anyways, we're not going to make improvements. Sorry, my brain is,
The square root of the number.
right. Once you go to the square root of the number, then you've done enough. Okay, so our homework assignment is going to be finish the telephone number code to all the letters of the alphabet. And don't just start working on that right now. I know you could do that in 5 minutes, and you may have already done it. But if you haven't, don't do it right now. And then write a loop that will count, or that will calculate the sum of all numbers between 1 and x that are divisible by 3. You know how to check to see if something's divisible by 3. If v% 3 is equal to 0, that's how you check to see if a number is. And let the user input x first. So those are our 2 pieces of homework that are associated with today's lecture. And the telephone number code is up here for those who are not here today. So it'll be included in the homework assignment. Now the neat thing to do will be to actually loop through a string so that we can enter a whole phone number. So we could type in 1-800-JAVA, and then it'll print out the numbers that are the equivalent of that. But for the short term, just getting this to work will be enough. All right, onward and upward. Did everybody get the for loop working? Raise your hand if you didn't. Loop comparison and then nested loops. Those are really just about the last topics we need to hit here because I think we've covered the rest of it. Loop comparison. Oh, we've done this too. When to use a for loop. Use a for loop when you know how many times it's going to repeat or you know the range. Do loop if you always need to do the repeated thing at least one time. While loop if you can't use the others. All right, a nested loop is when you have a loop inside of a loop. When you have one loop and then inside that loop is an indented loop. Just like you have nested if statements. We did nested if statements a while back, pretty sure. We can also nest loops. Let's do an example of one of those. I'm almost wishing we'd start a new program because we're having to answer all these questions, or we could go and put it up at the top. And let's put it down here. Okay, so let's draw a rectangle of asterisks that is 10 rows and 20 columns. So we want it to be 10 rows deep and 20 columns wide. And we really want these to be stored in variables so that they could be changed or the user could type in the size. So I'm not going to hard code in 10 and 20 inside my loop. I'm going to declare them beforehand. So I'm going to declare two variables. Max rows is equal to 10. Max columns, maybe I should just make it max row, take the S off, easier to type, is equal to 20. And now I'm going to use nested loops. Let's declare some counter, R for row. We're going to start it off at 1, and we're going to keep going as long as R is less than or equal to max row, R++. Inside that loop, we're going to nest another loop, just like Russian nesting dolls, where you have a little baby and then you have the mommy, a doll inside of a doll. Here we go. For int C for column is equal to 1. C is less than or equal to max row, C++. And we will just print out an asterisk. Not print line, because we don't want to go to the end. We don't want to start a new line after every single asterisk. We only want to start a new line when we're done with an entire row. So, looking at that, where should I stick my print line so that it won't just print, 200 asterisks? I don't want to stick it here because I don't want to only print one asterisk and then go to the next line. I want it to print. I have an error here. This loop should be max call, not max row. So go ahead and fix that while you're looking at it. But I bet one of y'all can tell me where to stick the end of line marker in this code. Do a print line in order to get it to print 20 and then go to the next line. Nobody can spot it?
Through the closing brace.
Right here. Yeah. The reason we're going to do that is because the inner loop is going to print an entire row, and then we want to go to the next line so we can print another row. So each time the columns are maxed out, we want to go to the next row. This inner loop prints out every column, and then the outer row prints the rows. So we'll stick a print line here to indicate that we're done. What number shall we factorial? 10. Is 11 a prime? I don't know. There we go. There's my 10 columns. Oh, I forgot to make the change. I forgot to change that to max call. There. Now it'll work better. There we go. If I only wanted to print a hollow box, if I wanted to print spaces, if we weren't on the edge, this is just kind of a thought question. What condition could I use to decide whether to print an asterisk or a space? I want it to be a hollow box, so the asterisks are only on the outside and not inside. Well, what is the value of row and column there? That's row 1, column 1, right? That's row 1, column 2, row 1, column 3, all the way out to here. So what is the value of this one? We would want that one to be a space to print a hollow box. So that's row what, column what? Somebody tell me. Well, you're right. If we had started counting at 0, that would be 1, 1. But in this particular case, we started our loop counter at 1. So that would be 2. 2, 2. And then down here, So I think we could do that just by checking to see if row and column are greater than 1. So I'm going to put an if statement here.
But not the max.
Yeah, right. If C is greater than 1, let's do R. If R is greater than 1 and R is less than the max row, now this is getting to be a long if statement, sorry. And C is greater than 1, and C is less than the max column, then we want to print a space, else we want to print an asterisk. I don't think that worked. I broke it. You know why? Because I made this a print line rather than a print. I had print L in there. Don't make the, on the printing of the space, don't do that. There we go, there's our hollow box. So the real point of this is to show nested loops. But I also wanted to show putting a condition inside of a loop. So we have nested an if statement inside of a loop, inside of a loop. Boolean variables. I know we've talked about them. Boolean variables are when you have a variable that's either equal to true or false. In this particular case, we used a Boolean variable. We did that up here. We set is prime equal to false. And most of your Boolean variables will be something like that, is something. Because it's a flag, and you're going to set it equal to true or false. So, you know, I name a lot of my Boolean variables is. Is done, is empty. You know, and if is empty is equal to true, you know it's empty. That kind of thing. You don't have to name yours like that. I could have just called it bool prime is equal to false, but I like for it to read more like an English statement. So we set that equal to false, and then later on we decide to set it equal to true. We could shorten this into a single line of code. Writing this, if factors is equal to 2, is prime is equal to true, is the same as doing this. Is prime is equal to, parentheses, factors equal to 2. Like that. So now I can remove these lines. That is a Python comment, not a Java comment. Okay, there we go. So why does that work? Because this is a logical expression that evaluates to either true or false. And if factors is equal to 2, then this evaluates to true. And we store true into is prime so that we can print out that it is prime. But if factors is not equal to 2, then is prime is set to false because factors equals to 2 will be false. So it evaluates that, and then it stores either the true or the false into is prime. So this is easier. I should say it's a more concise way of doing this. If you like writing it like that, that's totally cool. If you want to write it like that, that's totally cool. But if you want to do it like that, that's also totally cool. But I want you to be able to recognize both of them. So if I gave you some statements like this, int a is equal to 10, int b is equal to 20. Now I'm going to make some Booleans. Boolean, I don't know, t1 is equal to a less than b. Boolean t2 is equal to a greater than b. Boolean t3 is equal to b greater than 15. Boolean t4 is equal to a greater than 15. Tell me what t1, t2, t3, and t4 are. Are they true or are they false after this code runs? You don't have to type it in. I know you're probably already halfway there, but Is A less than B? A is 10, B is 20, A is less than B, so what's going to be stored in T1? True, because this expression evaluates the true. What about T2? Is A greater than B? No, so what's going to be stored in T2? False. Right, that makes sense. How about T3? Is B greater than 15? So, what's going to be stored in T3? Yep. How about T4? Is A greater than 15? No, so what's going to be stored in T4? Yeah, okay. We got that, right? Then you could do something. You could do if T1, then print, whatever, system.out.println, A is less than B, whatever. Whatever decision you wanted to make. Or you could write a while loop that depended upon a true or a false. Boolean is done is equal to false. Int counter is equal to 0. While counter is while not is done, or you could write while is done is equal to false. System.out.println counter. Let's increment counter. And then let's do this. Is done is equal to counter equal to 10. What numbers is this loop going to print out? What's the beginning number it will print? You can tell by what we initialize counter to. Yeah, we initialize counter to 0, so when we print it, we're going to print a 0. Then we're going to add 1 to it. Now counter is equal to 1. Well, is counter equal to 10? I know more than Hakan is awake. Did I hear? Okay, right, that's not true. So is done is still equal to false. So not is done is still true. I could rewrite that. This is the same thing as saying while is done equals false. Whichever way you want to write it is totally cool. If you would like writing it like that, that's cool. If you like writing it like that, it's cool. And so it's going to keep going until counter is finally equal to 10. It's going to print out 9, then it's going to add 1 to counter, and then it's going to set is done. Now counter is equal to 10, so if counter is equal to 10, that's true. Is done will suddenly turn true. Then when we come back up here to repeat our loop, is done still equal to false? No, it is not. So it's going to bail out. So this should print all the numbers between 0 and 9 if I've pieced that together correctly. And here we go, printing 0 through 9. Hope that makes sense. We've had several examples of loops now. For the one where you're supposed to enter the number and then check to see, if it's a... That shouldn't be too hard. I'm not going to talk about that further. But if you get stuck, of course, ask me. Text me, whatever. So Boolean variables. We understand what they are. Input validation. Haven't we done this already? Input validation is when you check to see if they have typed in a valid piece of data. This program here wants them to either press enter or to enter a queue to quit. Now that's kind of silly, but we could do the same thing. Something similar. I'm going to go back to my code. I'm going to close C++ because I didn't mean to launch that. I'm going to ask the user to enter a value. Enter a number between 1 and 10. Then I'm going to store that. Int num is equal to scanner.nextInt. Then we're going to check. We're going to see if it's right or wrong. While number is less than 1 or the number is greater than 10, it's a bad number. So we're going to print an error message, system.out.println, invalid value. Then we need to print out our message again, system.out. I guess I already had used num before. Okay, take out the int in front of num because we'd already used num before. We need to tell them what to do again. Enter a number between 1 and 10. And then we need to let them type that in again. This traps them until they type in a good value. This while loop checks to make sure that they have entered an invalid value. And if they have, it goes into the while loop and it stays in the while loop as long as it's an invalid value. And how do we define an invalid value? If it's less than 1 or if it's greater than 10. So run it, and then at the very last question where it says enter a value between 1 and 10, type in 0. It should say invalid value. Enter a number between 1 and 10. This is a very common style, and it's what the book shows you. It requires what's known as a priming read. You know, if you prime a pump, you know, or something like that, you have to, you know, do something before. Here, this is a priming read. Before the while loop even begins, we have to store something. We have to ask them, and then we have to get the input. I don't like this kind of loop because it makes us repeat code. This print statement and this next int are done twice. Notice that we do that there and we do that there as well. We can fix that. We could write it a different way. We could use a do loop, or we could use a while true loop. Let's use a do loop, because our definition of a do loop is when we have code that we want to issue at least one time. Well, we have some code that we want to do at least one time, which is to ask them for a number. So let's do some stuff. What is our stuff? System.out.println. Enter a number between 100 and 200, just to change things up. Now let's read that in. Num is equal to sc.in next int. It would be nice if we printed an error message though, but I'm going to skip that for now. And after my closing brace, I'm going to put a while, and we're going to keep repeating while num is less than our minimum, 100, and make that an or while num is greater than the maximum. And then this is the only time you ever put a semicolon on a while loop statement, is when you're doing a do while. This does not require a priming read. So in general, this looks a lot better. Now it's not printing an error message the way this one is, and we could fix that. But first let's make sure this works.
Can we do for loops?
A for loop is not a good use for this. You could, because anything you do with a while loop, you can always do with a for loop. But you use a for loop when you know you're counting from one number to another. And here we're not counting. We're just asking the user for input. So what number shall we? Factorial 10, enter a possible prime, 10, enter a number between 1 and 10, 10. Now enter a number between 100 and 200. I'm going to type 300. It's not between 100 and 200. It didn't print out that it was an error, but it did say enter a number between 100 and 200. So why don't we go ahead and add our error message. if number is less than 100 or number is greater than 200, print invalid input. System.out.println. Now I still don't like this loop. And somebody tell me why Professor Thompson doesn't like this. And remember that Professor Thompson hates duplicated code.
You have your criteria in there twice.
Right, our condition is in there twice. We can fix that by making it a while true loop. That's my favorite user input validation. That would look like this. While true, but to get that to work, we have to use a break statement. System.out.println number between 1,000 and 2,000. Number is equal to sc.nextInt. If number, now we have to switch gears. We're not checking to see if it's wrong, we're checking to see if it's right. So we're not going to check to see if it's less than our minimum and greater than our maximum. We're going to see if it's greater than or equal to our minimum, which is 1,000, and it's less than or equal to our maximum, which is 2,000. And if both of those cases are true, we're going to print break. We're not going to print break, we're going to break out of the loop. Otherwise, we're going to display an error. All right. Is that much better than the do loop up there? Not really. It does exactly the same thing functionally. But I don't like having to type the condition twice because I might make a mistake. I might write the condition once here, correct, and then I might make it incorrect there. Anytime you can eliminate duplicate code, you're making your program better. So this is my preferred way of doing input validation, this third way. If you wanted to do this as a for loop, it would look really weird. So I'm going to decline to do it as a for loop. All right, guys, I think we're done for today. Let's make a Dropbox. You can put your telephone number program in there if you want or not, but I do want to see all the loops in there.